So we learned that reaction rates increase with increasing reactant concentration. In a reversible reaction, the reaction can proceed in both the forward and the reverse directions. So as the reactants react, their concentrations go down, and the rate of the forward reaction slows down. As those products form, the concentration of the products, which are the reactants for the reverse reaction, increase, causing the rate of the reverse reaction to increase. At some point, you get to a balance where the rates are the same, and that's called equilibrium. Okay, this is a figure from the textbook. It looks really cool and everything, but it needs a little explaining. So up here, we're representing time. This is at the beginning, a little after 15 seconds, a little after 30 seconds, a little after 45 seconds. And this is the reaction. We're looking at white and violet going to these molecules, right? So here we have only reactants. So the reverse reaction cannot happen at all because there's none of these guys there. What we're looking at here, this is a function of time, the concentration of these different things. So initially the concentration of the product is 0, and the concentrations of the two reactants are high. As the reaction progresses, the reactant concentrations come down as they get reacted, and the product concentrations come up. And these will continue, the one will go up and the others will go down until they reach a point where they don't change anymore. And this area is called dynamic equilibrium. It's dynamic because it's not that there's nothing reacting, that it just came to a point, it's like, okay, we're balanced here, let's stop. You still have a lot of stuff happening. You have the forward reaction going and the reverse reaction going, but they're going at the same rate. And so if you look at the overall concentrations of reactants and products, they're not changing. But what's happening is those individual reactants and products are reacting and going back and forth in both ways. They're very busy. Dynamic equilibrium, condition in which the forward reaction rate equals the reverse reaction rate. We have both reactions still occurring, and it's very important to understand that the concentrations of reactants and products are not changing, but they are not equal to each other. This isn't half of this reacted, and so now we have equal concentrations. There are some reactions that will end up like that, but the relative concentrations depend on the value of the equilibrium constant. So you can have an equilibrium where you have hardly any products, or hardly any reactants, or anywhere in between. It all depends on the equilibrium constant. So in an earlier edition of TRO, this, oops, I don't want to do that. This was, dang it, this was Narnia, and this was Middle Earth. And I thought that was just a lot more fun than Country A and Country B, right? So initially, there's a lot of people over here in Narnia, and there's not very many people over there. There's hardly any people here, so they're not going to move to Narnia, right? There's not very many of them to do it, right? Over here, we've got lots of people. Now, a lot of them are going to stay here, but some of them are going to move to the other side, right? And as emigration from Narnia to Middle Earth continues, then the population of Middle Earth grows, and more people start migrating or emigrating from Middle Earth back to Narnia. And at some point, you'll reach a balance where the populations of both countries are stable. But which one's higher depends on which one's nicer to live in. Yes?
So does this like relate to, I guess, in biology where we have like an electrochemical equilibrium with all the different gradients or for concentrations like how it's explained here?
Well, equilibrium is very important in biology. Yeah. So, yeah, go ahead.
So the products and reactants don't have to be on equal to each other, just in the middle, in the direction they're going is equal. So
The rate
yeah,
of forward and reverse reaction is equal.
Mhm.
It says nothing about the relative concentrations. If Middle Earth had some great pestilence or something, or a whole bunch of, we could apply this at current times, but I'm not going to. It's a bad place to go. But let's say there was some pestilence here and all the crops were destroyed, right? Is this equilibrium going to change? Yeah, right? This isn't a very desirable place anymore, right? So you're going to have more people move to Narnia than move to Middle Earth, but at some point it's going to become an equilibrium again. Which statement does not generally apply to a chemical reaction in dynamic equilibrium? The rates of the forward and reverse reactions are equal. The concentrations of the reactants and products are constant. The concentrations of the reactants and products are equal. Which is not true. C. It's easy to think that way. It's kind of the natural thing to assume, which is why I'm kind of harping on it. It's because it's not true, and it's going to cause you problems if you don't recognize that.